Hello students, good morning. Today, let us continue yesterday's chapter. Where exactly I stopped. I will start from that point only. In yesterday's class, we were discussing about what? Work function. What is work function? You know. What is work function? Work function is minimum energy required to remove electron from metal surface. Electron volt. Electron volt is defined as it's the energy gained by electron when it is accelerated by applying potential difference of 1 volt. And 1 electron volt is equal to 1.6 into 10 raised to minus 19 joules. Pi naught is equal to h nu naught. Or I can extend this equation as hc by lambda naught also. Visible? Probably not visible. hc by lambda naught also. And we are trying to understand about different types of electron emissions. Types of electron emissions. Okay, very important concept as I discussed earlier. First one is thermionic emission. What is thermionic emission? Thermionic emission. It is the emission of electron from a metal surface by supplying energy in the form of heat. It is called thermionic emission. What about second emission is field emission. What is field emission? Here field means electric field. Here field means electric field. By applying electric field of order 10 raised to 8 volt meter per second. Volt per meter. 10 raised to 8 volt per meter. We can liberate electrons from metal surface. This is called field emission. This process is called field emission. What is field emission in sentence? Field emission is a process of emission of electrons from metal surface by applying very high electric field of order 10 raised to 8 volt meter raised to minus 1. There is one more emission, very important for this as far as this chapter is concerned. ಈ ಚಾಪ್ಟರ್ ಸಂಬಂಧಿಸಿದ ಹಾಗೆ ಮತ್ತೊಂದು ಎಮಿಷನ್ ಇದೆ. ಆ ಎಮಿಷನ್ ಅಂತ ಹೇಳ್ತೇವೆ ಫೋಟೋಎಲೆಕ್ಟ್ರಿಕ್ ಎಮಿಷನ್ ಅಂತ ಹೇಳ್ತೇವೆ. What is photoelectric emission? It is a process of emission of electrons from metal surface. It is a process of emission of electron from metal surface. This is metal surface. Visible? This is metal surface. This is metal surface. Process of emission of electron from metal surface. When radiation, I will represent radiation by this fashion. Radiation is equal to h nu of suitable frequency. Suitable frequency, say nu naught, is incident on metal surface. What I said? Photoelectric emission is a process. Photoelectric emission is a process of liberation of electrons or electron from metal surface when radiation, light energy of suitable frequency plays very important role in this chapter, in this concept. Remember, frequency plays very important role. So called threshold frequency of suitable frequency is called photoelectric emission. Okay, so our fourth important definition to be remembered in this chapter is, this is third one, fourth one, very important is threshold frequency. Threshold frequency. Nu naught. Threshold frequency, nu naught. Threshold frequency. What is threshold frequency? It's a frequency. It's a frequency of what? Frequency of incident radiation. Where? From metal surface. It's a frequency of incident radiation on metal surface below which no photoelectron is liberated. Below which no electron is liberated. Actually, ಏನು ಮಾಡಿದ್ರು ಲೈಟ್ ನ ಇಂಟೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಮಾಡ್ತಾ ಹೋದ್ರು. ಇದು ಮೆಟಲ್ ಸರ್ಫೇಸ್ ಅನ್ಕೊಳ್ಳಿ, ಇದು ಸೋರ್ಸ್ ಅನ್ಕೊಳ್ಳಿ, ನನ್ನ ಕೈ ಇದು ಸೋರ್ಸ್, ಇದು ಮೆಟಲ್ ಸರ್ಫೇಸ್. ಈ ಮೆಟಲ್ ಸರ್ಫೇಸ್ ಮೇಲೆ ಇಂಟೆನ್ಸಿಟಿ ಹೆಚ್ಚು ಮಾಡ್ತಾ ಹೋದ್ರು, ಇಂಟೆನ್ಸಿಟಿ ಲೈಟಿನ ಇಂಟೆನ್ಸಿಟಿ ಹೆಚ್ಚು ಮಾಡ್ತಾ ಹೋದ್ರು. ಎಲೆಕ್ಟ್ರಾನ್ ಎಮಿಷನ್ ಆಗಲಿಲ್ಲ. ಎಲೆಕ್ಟ್ರಾನ್ ಎಮಿಷನ್ ಆಗಲಿಲ್ಲ. ಆಗಿದ್ದಿದ್ರೆ ಅಕಾರ್ಡಿಂಗ್ ಟು ವೇವ್ ಥಿಯರಿ ಸೆಟ್ಲ್ ಆಗಿಬಿಡ್ತಿತ್ತು ಅನ್ನೋದು ಇಶ್ಯೂ. ಆಗಲಿಲ್ಲ. ಕೊನೆಗೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ರೇಂಜ್ ಜಾಸ್ತಿ ಮಾಡ್ತಾ ಹೋದ್ರು. ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ಲೈಟ್ ಅನ್ನು ಜಾಸ್ತಿ ಮಾಡ್ತಾ ಹೋದ್ರು. For particular frequency, they observed just liberation of electron from metal surface. That frequency at which electrons are just liberated from that metal surface is called threshold frequency. Threshold frequency. That's why it is defined as it's a minimum frequency. It is a minimum frequency below which no photoelectron is liberated, no electron is liberated, no electron is emitted from metal surface is called threshold frequency. I can add one more thing here. Point number 5, threshold wavelength. Say threshold wavelength. I'll write somewhere here. We know pi naught is equal to h nu naught, or we can extend in yesterday's class I discussed this h nu by lambda naught. Where lambda naught is called threshold wavelength. Threshold wavelength. Threshold wavelength. Visible? Correct. Threshold wavelength. Lambda naught. What is threshold wavelength? Threshold wavelength is a wavelength above which no photoelectron is liberated, or no photoelectric effect is observed. Threshold wavelength above which no photoelectric effect is observed. Threshold frequency below which no photoelectric effect is observed. Please remember this points. Okay. Threshold wavelength is a maximum wavelength. You can just add that term also. Threshold wavelength is a maximum wavelength above which no photoelectrons are liberated, or no photoelectric effect is observed. Okay, or no photoelectric effect does not take place. Threshold wavelength is a maximum wavelength above which your photoelectric effect does not take place. Threshold frequency is minimum frequency below which your photoelectric effect will not take place. You cannot say photoelectric effect. So these 5 points you have to remember for 1 mark and 2 marks. Sometime 3 marks also remember. 1 mark, 2 marks and 3 marks. ಇವಿಷ್ಟನ್ನು ಕಮಾಂಡ್ ಮಾಡಿ ಕೊಡ್ತಾರೆ. ಪಾರ್ಟ್ ಸಿ ಅಲ್ಲಿ ಬರ್ಬೋದು, ಪಾರ್ಟ್ ಎ ಅಲ್ಲಿ ಬರ್ಬೋದು, ಪಾರ್ಟ್ ಬಿ ಅಲ್ಲಿ ಬರ್ಬೋದು. ಇಂಪಾರ್ಟೆಂಟ್ ಡೆಫಿನಿಷನ್ಸ್ ಯಾವ್ಯಾವುದು? ವರ್ಕ್ ಫಂಕ್ಷನ್, ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಕನ್ವರ್ಷನ್, ಮತ್ತೆ ಟೈಪ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಎಮಿಷನ್, ಥ್ರೆಶೋಲ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ, ಥ್ರೆಶೋಲ್ಡ್ ವೇವ್ಲೆಂತ್. ಪ್ಲೀಸ್ ರಿಮೆಂಬರ್. ಓಕೆ, ಪಾರ್ಟ್ ಎ ಬಿ ಸಿ ಯಾವ್ದಾದ್ರು ಬರ್ಬೋದು. Next concept is photoelectric emission. Photoelectric emission. Photoelectric emission. What do you mean by photoelectric emission? Or photoelectric effect, I will like better. Photoelectric effect, better term. Instead of emission, I will write effect. Photoelectric effect. It is a phenomenon. Photoelectric effect is a phenomenon in which electrons are liberated from some metal surfaces when radiation of certain frequency is incident on that metal surface. It's a phenomenon of emission of electrons from metal surface when radiation of some suitable frequency is incident on that metal surface is called photoelectric emission and photoelectric effect. This photoelectric effect was first observed by Heinrich Hertz. Here we have to study Hertz's observation, what he observed while doing experiments related to electromagnetic waves, detection, propagation of electromagnetic waves. He observed this phenomena also, this photoelectric effect phenomena also. This effect was literally explained, very well explained by Albert Einstein in 1905 with the help of Max Planck's quantum theory, where he applied Max Planck's quantum theory, particle nature of light, and emission of electron as an exchange of energy at a subatomic particle level. We will discuss it here very neatly. Now, question is, what is that minimum frequency required? We have discussed that minimum frequency required is called threshold frequency. That minimum frequency required is called threshold frequency. Here too we have to study what? Work function we have to note here. Work function I naught, threshold frequency. Threshold frequency. No. Threshold frequency. There are certain materials, metals. This photoelectric effect depends on nature of that metal, surface condition of that metal, nature of that material, like zinc, lithium, magnesium, sodium, these are some good examples for this metal surfaces, metals which easily undergo your photoelectric effect, or we can observe photoelectric effect, or the energy required to remove those electrons from these metal surface is easy. Or simply work function for these metals is less. These are very good, brilliant examples for your photosensitive materials. These materials are called photosensitive materials. Photosensitive materials we call. We call it them as photosensitive materials. Photosensitive materials. Photosensitive materials. Zinc, lithium, magnesium. Okay. You can add rubidium also. Rubidium, cesium also. Rubidium and cesium also. These are all photosensitive materials. It is sensitive, photosensitive, photosensitive materials. I'll write somewhere here. See, zinc. This is called photosensitive surface. Photosensitive surface, nature of that material, surface. Electrons liberated here by applying a certain radiation. Usually, UV radiation is used. There are certain materials which are sensitive to UV. There are certain materials which are sensitive to even visible light also. In this chapter, most of the cases they have used UV related what? UV sensitive materials also only. UV means ultraviolet. Ultraviolet is one of the electromagnetic electromagnetic radiation. You know that. When ultraviolet ultraviolet radiation is allowed to fall on certain photosensitive surfaces. Remember, photosensitive substance is a term used in future, which is used as a surface to remove the electron. Here, electron removed is called photoelectron. Remember, the term used is photoelectron. It's the electron, usual electron. Here, in this case, we have to use it as a photoelectron. If this photoelectron is allowed to flow through certain system, certain arrangement, then we produce current. Of course, electric current. This electric current is called photoelectric current. Photoelectric current. Photosensitive material, photosensitive surface, photoelectron, photoelectric current. The terms we must know. Okay, the terms we must familiar with the in this concept. Okay, fine. Now, Hertz observations. We have to study this point. Hertz observations. It's not so important anyway. Hertz observations. Okay. I need some third chapters. This is thick metal plate. This is metal plate. This is not very important, and even you are not supposed to remember all those things. Just I will use one more. Here P1 and P2 are metal plates. R2. These two are copper rods. This is induction coil. This is induction coil. Induction coil. These are A and B, very nicely polished spheres. We have certain loop here. This is called loop, metal loop, usually called detector loop. Detector loop. Here too we have some small spherical balls, metal balls, which are very nicely polished, called C and D. C and D. In this arrangement, okay, we observe sparks. This is R, detector loop. We observe sparks. What spark? Electric spark observed. Electric sparks are observed. Electric sparks andre spark kidi ಬೆಂಕಿ electric ಕಿಡಿಗಳು ಇರ್ತಲ್ವಾ were observed. This arrangement used by Hertz to study generation and propagation of electromagnetic waves basically. ಇದನ್ನು ಅವರು ಸೆಟ್ ಮಾಡಿದ ಯಾವ್ದಾಗಿತ್ತು, ಜನರೇಷನ್ ಅಂಡ್ ಪ್ರೊಪಗೇಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ವೇವ್ಸ್ ಅನ್ನ ಜನರೇಷನ್ ಮತ್ತು ಪ್ರೊಪಗೇಷನ್ ಮಾಡೋದಕ್ಕೆ ಸೆಟ್ ಮಾಡಿದ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಆಗಿದೆ. This setup consists of two metal plates T1 and T2, two copper rods R1 and R2, two polished spheres, metallic spheres connected to induction coil. What is induction coil? You know that. Chapter number 7-6, induction coil. This loop is called detector loop. Metal wire. When high voltage is applied, usually we observe what? High voltage sparks, high voltage sparks between C and D. Voltage sparks are sparks, electric sparks are observed between C and D. This is detector loop. Hertz just allowed ultraviolet radiation to fall on this detector loop. Hertz ಏನು ಮಾಡ್ತಾರೆ, ಅಲ್ಟ್ರಾವೈಲೆಟ್ ರೇಡಿಯೇಷನ್ ಅನ್ನ ಈ ಲೂಪ್ ಮೇಲೆ ಬೀಳೋ ಹಾಗೆ ಮಾಡ್ತಾರೆ. ಅಲ್ಟ್ರಾವೈಲೆಟ್ ರೇಡಿಯೇಷನ್ ಈ ಲೂಪ್ ಮೇಲೆ ಬೀಳೋ ಹಾಗೆ ಮಾಡ್ತಾರೆ. Hertz observed these high voltage electric sparks enhanced. These high voltage electric sparks enhanced, increased when there is incident, when UV radiation is incident on this detector loop. Let me repeat. In his setup, in his experimental setup, to detect and detect electromagnetic waves, Hertz irradiated, allowed to fall ultraviolet radiations on this detector loop. When these ultraviolet radiations are allowed to fall on this detector loop, he observed enhancement, increase in high voltage electric sparks, high voltage spark between C and D. He observed increase in spark. He just noticed there must be an emission of something. emission of some thing, some object, some material, as there is increase in, there was increase in what? There was increase in electric spark. This observation he mentioned. He just wrote down this observation. This is called Hertz observation. Hertz observation. This is called Hertz. Okay. In his observation, Hertz observed enhancement of. Okay. Next, we have to study Leonard's observation, or Watches and Leonard's observation. Okay. We will study that in next class. Okay. Hallward and observations, Watches and Leonard observations, and experimental observations of photoelectric effect also. Experimental observations of photoelectric effect also we have to study. Okay. Yes. Thank you. Watch this video part 1 and 2. Okay. Then we will move part 3.